good morning and welcome to my thesis defense. Thanks for being here. Before we start, I would like to give the word to Andy for some opening words.
Well, thank you, Casper. Welcome to this very well-organized online streaming event. Well, normally we like to do our thesis defenses on campus, but it's probably one of the final ones that we do online, and Casper prepared a show for you today. Let me quickly explain what's going to happen today. Well, Casper is obviously here to talk us through what he has been doing over the past 9 months or so. That will take around half an hour. This will all be in English, as we are an English educational program. After that half an hour, there will be time for questions. There can be some questions from the audience, but the most difficult questions will probably come from that audience, and then the easy questions remain for the committee. The committee is composed of Dr. Katsifodimos, an assistant professor from the Web Information Systems group, also Caroline Brandt, PhD student in the software engineering group, and finally myself, Andy Zuidman, full professor in the software engineering research group. After that, the committee will withdraw for some 20 minutes, so stick around if you want to discuss more with Casper. After 20 minutes, we return with our verdict, and then hopefully a lot of celebrations today in Delft or online. You can choose. That being said, Casper, the floor is yours.
All right, thanks a lot. Let's get started then. So, good morning again. Today I'm going to talk about what I've been working on for the last 9 months, which is TestAxis, an IDE plugin to inspect CI build test results. So, what are we going to do today? Well, I'll start by explaining what problem I really try to solve, and then once you understand the issue, I will show you our attempt at solving it, which is TestAxis. I'll give a demo of TestAxis and talk about all the features that it has. Then, to measure the degree to which TestAxis actually solves these problems that we identified, we conducted an experiment in which people actually got to work with TestAxis. And I'll tell you more about that later and also share the results of that experiment with you. And then finally, I'll talk about some of the key takeaways of my presentation and my thesis. So now that you have an idea of what I'm going to talk about, let's get started with what we are actually trying to solve here. And for that, I'll first give a little example. Imagine you own a washing machine. Well, you probably actually do own one or have access to one, but anyway, let's say you happily loaded the machine and pressed start. You already walk away, but suddenly you hear... You look back and see this. You probably think, oh no, not today. First, you try to see if you can fix the issue yourself, but the stupid machine only says error and does not give you much to work with. After half an hour, you give up and decide to call the repair service. They arrive 1 hour later, take a look at your machine, and well, as you can tell from the look of this repair person, it's not always immediately clear what the issue is for them as well. So they grab their computer and connect it to the washing machine to run their diagnostic software, and once it's finished, they get a whole lot of diagnostic information about your machine. Well, that sounds cool, but it includes a lot of information that the repair person does not need, and it does not say anything about the issue. However, since the repair person is experienced, they luckily know where to look, but it still takes half an hour before they actually find the issue. And it turns out the machine isn't getting any water. And then suddenly it hits you. You turned off the tap last night and then totally forgot to turn it on again. Well, and now that just cost you 2 precious hours of your day. So why did this actually take so much time? Well, in the first place because you made a small mistake, of course, but hey, that happens to everyone and it's difficult to avoid that. Then there's the time it took the technician to inspect the diagnostics report. But more importantly, the machine only said error on the screen, which does not help you find the issue at all. Showing a more descriptive error indication right on your machine would maybe have helped save you all the effort and made you remember that you turned off the tap earlier. Okay, well, obviously we're not going to talk about repairing washing machines today, but a lot of software developers actually experience situations similar to the one I just described every day. When a software developer works on a project, they often make changes to the software to add new functionality. A developer then takes the following steps. They create a change by writing new code in their local development environment. Then they push this change to a central point, like GitHub, that hosts the codebase. Before the change makes it into the production application, the push triggers a continuous integration, or CI build, that performs a number of checks on the application with a new change, to ensure that the whole application keeps working after introducing this new change. You could see such a CI build as an assembly pipeline. It, for instance, compiles, tests and statically analyzes a codebase when a new change is made. It tests the application based on tests that verify that the software results in a certain state after one or more actions have taken place. These tests can easily be repeated and therefore ensure that the behavior of the software is as expected. Every new change to the software project goes through this assembly pipeline. So, what does all of this have to do with washing machines? When a CI build fails, it's often not immediately clear to a developer what's going wrong. To find out more information on the issue, they can often only review a build log, similar to the long diagnostics report from the washing machine, and that log contains hundreds to thousands of lines of text and have the reason for the build failure somewhere hidden in them. You can imagine that it can take quite some time to find the reason, or even more importantly, the cause for this build failure, and that makes it a costly and tedious process to go through every time a build fails. So, just like the repair person, a developer could likely already be helped by some indications in this build log where the issue could be. However, like displaying a better error message on the washing machine, it would be even better if the developer can immediately see what is going wrong in their local development environment. So you can maybe feel where all of this is going, but let's first talk a bit more about the problem, because you may think, yeah, okay, it sounds annoying when my washing machine breaks down, but when does it actually happen? Maybe once every 10 years or something. CI builds, however, break a lot more often, in 13 to 35% of the cases. And when they do, a fix usually takes 42 to 59 minutes. And more importantly, the majority of CI builds fail due to failing tests, about 59%. And therefore, this is really what TestAxis focuses on. Everything until now mainly describes the second problem of the 4 problems that we identified, which is about the difficulty of identifying the cause of a CI build failure. But we also consider 3 other problems, starting with the problem of just becoming aware of a failing build in the first place. And this is an issue because on average it takes about 3 hours to become aware. And that could be very annoying for code workers that depend on your change. And it's actually not that strange that it takes this long, because only 28% of the developers really pays attention to this type of notifications. And they then usually get the notifications through email or through some messaging app like Slack. And when they do not use notifications, they are then often informed through colleagues or just manually check the build status. So yeah, this system of becoming aware is simply not great. And moreover, the current approaches like the email notifications really require you to switch context from your local development environment to your email client, for instance. So the third problem is the lack of assistance when a CI build provider offers when a CI build fails. Skipping the second problem since we already discussed that. And this really is a problem because, a CI provider usually shows the name and the stack trace somewhere in the build log, but that's often not enough to really pinpoint the issue and find why the test is failing. So therefore, we can say that CI providers like Travis and GitHub Actions, for instance, do not really support the debugging process any further, which they could do by offering an interactive stack trace where you could simply click the entries in the stack trace to browse to that relevant part of the code base, or by adding simple things like navigating to the test code of the failing test. So really a deeper integration into the development environment may help a lot in offering more assistance. And another way to do that is to show the production code under test. So really the part of the production code that the test is targeting. However, these connections between the test code and the production code are often not explicitly defined. For unit tests, it's maybe like quite simple because, well, they only most of the time cover one method, and then you can just take a look at that method. But for higher level tests, this connection is often not clear. So we need to infer those relationships, and a common technique to do that is to use code coverage. However, it's quite expensive to locally run all your tests all the time just to establish these links. So we want to do that in a different way. So these are really the four major problems that we are trying to solve, and we'll do that as follows. In short, we bring the CI build test results with some additional context to the IDE in the form of an IDE plugin. And the IDE is really the local development environment of a developer. And we do that to offer a similar experience to really just running a test locally. And in the plugin, we then show the test results, the stack traces, the test code, and the changed code under test. And the aim of my thesis was then to evaluate the different features of TestAxis in terms of the potential performance improvements and the perceived usefulness by developers. And we measured this by doing an experiment, a user study in which participants actually used TestAxis, and there they solved a number of programming assignments to measure this potential performance improvement, and also just to get some experience in using TestAxis to be able to reflect on its usefulness. The results then show that TestAxis is a successful step towards solving these problems, but we'll get back to that later. Let's first just take a look at what TestAxis does and what its main features are. And let me quickly have some water. Yeah, so let's take a look at what TestAxis actually does. The most important part of TestAxis is the IntelliJ IDE plugin. And I'm just going to show you how that all works. Well, in the meantime, I will describe which features tackle which of the problems I listed earlier. So let's take a look. I now have IntelliJ open here, the IDE for which we developed the plugin with the JPacman project, which is just a simple Pac-Man game implemented in Java. It's the same project as the developers used in the experiment. So let's assume we just pushed a new change and that this build for this change is now running. Then once the build is finished, we should receive a notification in the IDE, which looks as follows. And then we can click Inspect Results to open TestAxis. Well, this part alone is already our attempt at solving the problem of becoming aware of a build failure by notifying the developer in the IDE. So we can cross that one off the list. Then we just open TestAxis, and here on the left you can see an overview of all the builds. We can optionally filter the builds for the filtering options, but for now we'll just look at the most recent build. We can see here that it has 2 failing tests, or actually 2 failing test classes, and we can open that and then see that the player collides with pallet test is failing. So let's take a look at the test. Here on the right we see the name of the test, the runtime of the test, but also the error message as a part of the stack trace. We see that some value 0 is not the expected value of 10. And compared to just a CI build log, this should already help a lot in identifying the cause of the build failure. So let's cross that one off as well. This test view really tries to mimic the built-in test runner of IntelliJ to make developers feel comfortable. So just like in the built-in test runner, this stack trace is interactive. You can click an entry here and then browse through it in the main IDE window. And moreover, using this test name that we get from the build reports, we find the test method and show it here within the context of the entire test file, the test class in this case. And we do that to, on one hand, just help developers understand the intent of the test better, and therefore the test failure better, of course. And on the other hand, to simply spot, well, the simple mistakes that someone could have made in the test. And this then really is the first part of the system that TestAxis offers when a test fails. The second part has to do with the changed code under test feature on the next step. And here we can see all the files that are covered by this test. And it only shows the coverage of this specific test, so not of the entire test suite like most other coverage tools do. And we collect this using a custom Gradle plugin that we developed, and which is also available open source on GitHub. But we do not only show coverage information, we actually combine this information with the changes leading up to this build failure. And you can see over here there's a label changes covered, which simply means that that the changes that were made in the test that was that the changes that were made were covered by this specific test. And why is it relevant? Well, you can imagine that when a test is suddenly failing after a change that you made and the test really covers a part of that, then that part is likely to be a source of the issue. And here on the right, you can also see we actually highlight these lines. So this line is highlighted purple, and that means it's both covered and changed. So what do we mean by that? Well, let's take a look. We get that information as follows. We take the covered lines that are covered by the test and combine that with the diffs of the commits leading up to this build failure, starting from the previous build, and you see the relevant parts of that on the top right. And then we sort of take the intersection of this information to end up with only the relevant covered and changed parts. And compared to just the original coverage or change information, this means we just need to investigate less code, which is of course nice if you want to quickly find the issue. And indeed, we see in this case that this line is highlighted purple, and there's something weird going on here because there's a mover colliding with a mover. So the player is colliding with itself, but it should probably be colliding with the thing it collided on. And we can just edit that in line here in the in TestAxis itself with the full IDE support. And with that, we can cross the last problem off as well, the code under test identification. And there's of course much more to tell about TestAxis and how this all works. But for now, this was just the quick overview of what it does. And TestAxis is available open source on GitHub as well. So to measure how effective TestAxis really is at solving the problems, we conducted a user study, an experiment, in which participants got to use TestAxis. In total, 16 participants took part in the experiment, and each session took 19 minutes, in which the participants filled out a number of questionnaires and solved 8 programming assignments. The assignments were conducted fully remotely through Zoom, and it's important to note that it was a pre-experimental study, which means that we can only conclude that certain effects on the results happened after we introduced TestAxis, but not necessarily because we introduced TestAxis. And the idea is then that this justifies the need for a more in-depth experiment with more participants and a higher cost. So we actually sort of did 2 experiments in one. The participants started with the first part of the one group pre-test post-test study, in which they filled out a pre-test questionnaire on their background, their views on software testing and continuous integration, and also their expectations on the usefulness of TestAxis. Then we introduced TestAxis to them as a sort of abstract concept, but also they got to actually use it within subject study. And here they got 8 failing CI builds that they needed to solve, 4 without and 4 with TestAxis. And then after each assignment, the participants got a small questionnaire on how they really spent their time in this assignment. And this part of the experiment is then used to evaluate the potential performance improvement by measuring the time a participant needs to fix a failing CI build. And that's what we call the failure fixing time. So let's move on to the last part, which is the second part of the one group pre-test post-test study. And here the participants filled out a post-test questionnaire in which we asked questions about their experiences and opinions on the usefulness of TestAxis. So there were in total 8 different programming assignments, and they could all be solved with or without TestAxis. And when the participants were not allowed to use TestAxis, they had access to a pull request on GitHub together with a GitHub Actions CI build log. The assignments were divided into 4 categories, and each category has 2 assignments. So the categories are the test failure metadata, where the issue could be spotted from just the name and the stack trace. The test code category, where the issue was, well, in the test code. And for the last two categories, the issue could be spotted in the production code, and the fourth category was then had more difficult assignments than the third category. So the failure fixing time, which we talked about earlier, is actually kept by a time limit of 5 minutes for the first three categories and 10 minutes for the last category. So to avoid any learning effects or ordering effects where the previous assignments may influence the behavior in the next assignments, we randomly split the group in two. We actually did a couple of things, but to start, we randomly split the group in two for each category. So you can see two groups over here. And each half got then one assignment with and one assignment without TestAxis. You can also see over here. And for the results, we then checked per assignment if there was an improvement from the without to the with variant. And you can see that by following the purple arrows. And someone decided to start drilling over here, so I hope it isn't bothering too much. We only really consider this improvement valid when it shows the same improvement for both assignments of this category, because really only then we know that the results are not influenced by the group composition. So, and then on top of that, we randomized the order of all assignments again per participant to avoid even more learning effects. All right, so now that we discussed all the things about the experiment itself, let's take a look at the results. I'll first discuss the performance results for each of the categories, and I will then talk a bit about the perceived usefulness by the participants. But let's first take a quick look at what the group of participants looked like. So the participants had 4 to 12 years of experience in software development and was relatively uniformly distributed over the years. Half of the participants were a student, 3 were PhD students, and 5 were a software engineer. And then 4 of the students were in their bachelor's during the experiment, while 9 participants were either doing or had completed their master's. So let's take a look at the performance results now. For each category, I will tell you about the average duration, the performance improvements, and the number of people that hit the time limit when it's relevant. So for the first category, the issues could be spotted just from the name and the stack trace. So it was mainly about just showing basic information that you could also find in the CI build log, but now easier accessible in the IDE. And we see here that assignment 1A on the top right showed an improvement of 7%, and assignment 1B showed an improvement of a little over 19%. And because both assignments show the same trend, we can conclude that they are not influenced by the group composition like I just explained. And therefore we can say that there's an average improvement of almost 13.5%. Then through the post-assignment questionnaire, we could find out how developers thought that they spent their time. And because this category was really about showing the basic information about the test failure, it's interesting to look at how much time the developers really spent figuring out which test failed. And they rated all these type of questions on a 1 to 5 Likert scale. And you can see here that they rated this particular statement on spending time figuring out which test failed lower when they were using TestAxis. So that's a nice result. Then in the second category, which was about the issues that can be spotted in the test code, we saw some nice improvements as well. So for assignment 2A, we saw an improvement of almost 18%. And for assignment 2B, we saw an improvement of a little over 10%. And on average, because it shows the same trend, it gives an improvement of almost 14%. In this case, it was interesting that a lot of people hit the time limit. So for assignment 2A without TestAxis, actually only 2 people managed to solve the assignment in time. But we still included the time limits in the overall results. So it does not influence the percentage. Then for category 3, the issues could be spotted in the production code on the test. And here we saw an average improvement of almost 50%. Assignment 3A showed an improvement of almost 30%, and assignment 3B of almost 70%, which is quite a lot, and which is also why we see that this improvement was statistically significant for a p-value of smaller or equal to 0.05, which is quite nice that we have a relatively small sample size. Then let's take a look at the last category here. The results looked a bit different because for assignment 4A we saw that there was actually a decrease when using TestAxis. For assignment 4B there was an increase of 31%. But because the trend of both assignments was different, assignment 4A showed a decrease and assignment 4B showed an increase, we cannot rule out the potential effect of the participant distribution in this category, and therefore we must conclude that the results for this category are inconclusive. So you may wonder, why was there then no improvement for assignment 4A? Well, of course, we tried to analyze that. We found that the demography of the both groups doing this assignment was actually quite similar, so it's probably not that, but we also looked into something else. So we saw that the participants of the with TestAxis variant of assignment 4A actually spent more time understanding the test code and were therefore focusing on the wrong things since the assignments were about the code under test. So this could be because this is simply emphasized more in TestAxis. It really shows the test code on a separate tab in the TestAxis window, whereas on GitHub it maybe shows it in the files changed if it's changed, and otherwise it wouldn't show up there at all. It could also simply point to a lesser understanding of the test or the assignment within this group. A nice overall result was that we saw for all categories that participants spent a lot less time running the failing test locally when they were using TestAxis. When they were not using TestAxis, we actually saw that the participants ran the failing test locally quite often just to get more information on the test failure. And this of course actually suggests that TestAxis shows some useful information, so that's nice. And speaking of usefulness, in the post-test questionnaire we of course asked a number of questions on how the participants perceive the usefulness of TestAxis. And for each assignment with TestAxis, the participants got shown a CI build notification. And the majority of the participants actually thought that these build notifications would make them aware of a build failure earlier. So that's nice. And they also said that, or thought that they prefer the TestAxis IDE notifications over their current approach. Then looking at the overall usefulness of TestAxis, the participants found that TestAxis was useful in helping them understand the test failure better and also fix it more quickly. And they consider all three main features, so the meta information, the test code, and the code under test feature to be useful. And obviously the code under test feature was considered most useful. And then we also compared the participants' expectations of TestAxis, which they indicated in the pre-test, to their perceptions from the post-test. And here we found that the TestAxis mostly meets or exceeds the expectations of the participants. The participants say that TestAxis would save them time and would therefore make it a part of their workflow. They were not extremely convinced that TestAxis provides enough information by itself to fix a failing CI build, but they still agreed with the statement, so not too bad. And they actually strongly agreed that TestAxis just provides benefits over inspecting a CI build log manually. So these were really all the results I wanted to share with you. Let's move on to some conclusions now. Okay, based on the results I just showed you, there are really 5 highlights that I want to share that really summarize the main outcomes of our research. So let's go over them one by one. First of all, we found that showing the CI build test failures in the IDE over CI build log positively influences the failure fixing time. Just purely displaying it already improved it by almost 13.5%. And then we also conclude that when a test fails due to an issue in the test code, using TestAxis will actually help you solve the issue more quickly by almost 14%. And TestAxis may actually also help you understand the test code and therefore the test failure better, but this is not something we looked into in isolation, but may still be included in the overall results. So then we conclude that showing the changed code under test has a positive influence on the failure fixing time as well. While we do not have conclusive results for the advanced cases, we did see an improvement of almost 50% for the other cases. Then on the usefulness side, we found that the majority of participants thought that the CI build notifications in the IDE would make them aware of a build failure earlier. and that they would prefer this over their current approach of becoming aware of a build notification. And then in terms of the general usefulness of TestAxis, we found that the participants consider the features of TestAxis to be useful, the code on the test feature to be the most useful feature, and most of the participants would actually want to make it a part of their workflow because it would save them time. And overall, they just find that TestAxis helps them understand failing tests better and therefore fix them more quickly. So just to wrap up, one of the participants summarized TestAxis as follows. They said that they thought that TestAxis was super useful during the experiments and continued with, I much rather preferred using TestAxis over the traditional CI logs on GitHub. What TestAxis does, in my opinion, is recreate the steps I manually take on a GitHub pull request to identify a failing test. And it does so in the IDE, so I don't have to switch steps and interrupt my workflow. So in summary, TestAxis helps developers solve failing tests more quickly by 13 to 50%. And the participants found that the features of TestAxis are useful and therefore they would incorporate it in their workflow to save them time. So this was really all I wanted to share with you about my work today. Of course, there's much more to tell. It's not really time for that. You can read my thesis if you want. Or otherwise, just ask a question in the Q&A section, which we will move to now on Zoom. The link should be over there next to the player. And I will give you a couple of minutes to switch to Zoom. I also have to switch to Zoom. And if you cannot join the Q&A session, then I would like to thank you for attending my presentation. I appreciate it a lot. And otherwise, I'll see you in a minute. Thanks.